This video is about implication and equivalence. Implication: if two propositions can be linked with if-then, then we have an implication. This is the symbol for implication. We read as if P then Q, or P only if Q. P is sufficient for Q. Q is necessary for P. In this implication, P is the antecedent and Q is the consequent. Equivalence: if two propositions are linked with the if and only if, then it's an equivalence. This is the way to show equivalence. In other words, two statements are equivalent if one implies the other and vice versa. Let's talk about two tables with implications. True, 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 false, false, true, false, false. All are true except this. Think about when antecedent is true while the consequence is false, means the whole statement will be false. Then this is a true, this is a true, this is true. True tables with the equivalence. We will write down true, 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 false, false, true, and false, false. Word equivalence means must be the same. So when you have true, true, this is true. False, false will be true. This will be false and false. Let's interpret these truth tables. This truth table will be given in the IB exam. But if you know the meaning, how to make this truth table, it will be easier for you to do the problem about truth table. This symbol meaning and, to be true, both must be true. This symbol means or, to be true, at least one must be true. This symbol means or but not both. To be true, exactly one must be true. This symbol means not P, the opposite of P. This is an implication. If P, then Q. All true except true, false. This is equivalence. P if and only Q. To be true must be the same. Guided practice 1. Show that the following proposition is a tautology. We will set up true, 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 false, false, true, and false, false. So we do P or Q, but not both. P and Q. Then we have P or Q, but not both, or P and Q. Then we do P or Q. Then we have if P or Q, but not both, or P and Q. Then P or Q. P or Q, but not both. You can get the answer from here. That's false, true, true, false. Exactly one true is true. Then for P and Q means both true is true. So here's true, then false, false, false. Now let's go to these two, do the OR. When you do OR, you can check. For both false is false, rest of them is true. So both false is false, true, true, true. For P or Q, it's here. We can get the true, 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 false. Now we got to do these two columns. Do implication. All true except true, false. We don't have true, false. So this is a true, 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 true. Since this proposition all true, which means this is a tautology. Guided practice 2. 3 propositions P, Q, and R are defined as follows. P, the water is cold. Q, the water is boiling. R, the water is warm. For A, write one sentence in words for the following logic statement. Not P and not Q implies R. Write one sentence means you have to use keywords. Implies, that means you have to use if, then. Not P, not Q, and we can use this is not. This means and. Therefore, here's the sentence. If the water is neither cold nor boiling, then the water is warm. Here's the keywords. If, then, neither, nor. Let's go to B. Write the following sentence as a logic statement using symbols only. The water is cold if and only if it's neither boiling nor warm. Here's the keywords. If and only if. We got to use this symbol. Neither nor, that means not and not. The water is cold, that's P. It's neither boiling, that's not Q, and not warm means R. Let's rewrite this. P, if and only if, not Q, and not R. Let's go to guided practice 3. 2 propositions P and Q are defined as follows. Jones passed this course, that's P. Q, Smith passed this course. A, write this symbolic form. Neither Jones nor Smith passed the course. Neither nor means not and not. So we have not P and not Q. This will be the symbolic form. Second one, it's not the case that Jones and Smith both pass the course. Both pass the course means P and Q. Not the case means negation. Therefore, this will be the symbolic form for second one. So here, not the case means negation. For B, complete the following truth table for the logic statement. Not P means the opposite of P. So we have false, false, true, true. Then we do not P or Q. We got to use these two columns to figure out not P or Q. For all to be true, at least one must be true. You can check from here. So whenever you see true, this must be true, true. Here's true. Then this will be false. Guided practice 4. Let propositions P, Q, and R be defined as P. Matthew arrives home before 6 o'clock. Q. Matthew cooks dinner. R. Jill washes the dishes. For A, express the following statement in logical form. If Matthew arrives home before 6 o'clock, then he will cook dinner. Keywords, if, then, that means this symbol. Matthew arrives home before 6 o'clock, that's P. He will cook dinner, that's Q. This will be the logical form. Second one, from A. Write the following logic statement in words. This symbol means if, then. This symbol means not, not. Therefore, we can write if Matthew doesn't cook dinner, then Jill doesn't wash the dishes. Now let's copy and complete the truth table below. For if P, then Q. This is the one. All true except true, false. That's the rule. So true, false. That is false. True, false, false. Rest of them will be true. If Q, then R. Still, all true except true, false. True, false. That's false. True, false. This is a false. Rest of them will be true. Not R means opposite of R. So we have false, true, false, true, false, true, false, true. These three columns, we do AND. When you check and, you could see the rule that is to be true, both must be true. Only this is true. Therefore, you will have to check all must be true, then you have a true. Rest of them will be false. Not P. That's opposite of P. So you have false, 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 true, 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 true. Then you need to check this is a true statement. We have this column and this column. This is an implication. All true except true, false. So just check true, false. No, we don't have true, false. So this is right. Second question from B. Explain the significance of the truth table above. First of all, we know this logic statement is a tautology. Or you could say the argument is valid. If Matthew arrives home before 6 o'clock, then he will cook dinner. If Matthew cooks dinner, then Jill will wash the dishes. Jill didn't wash the dishes. Therefore, Matthew didn't arrive before 6 o'clock. Guided practice 5. The truth table below shows the truth values for the proposition. A. Explain the distinction between the compound propositions. For P or Q, but not both. That is for this. For this, compound propositions means not P or not Q, but not both. B. Fill in the 4 missing truth values on the table. Not Q means opposite of Q. Therefore, this is true. P or Q, but not both. To be true, exactly one must be true. When you take an IB exam, these truth tables are given. So always check from here, get the rule. To be true, exactly one must be true. Therefore, you will have this is a false. Now look at these two columns. We do or, but not both, which means exactly one must be true. Then it's true. So check these two columns. We need only one true. That must be true. Otherwise will be false. Now let's check these two columns. We do implication. For implication, all true except true, false. Therefore, this must be true. For C, state whether the proposition this is a tautology, a contradiction, or neither. Since this is all true in all situations, Therefore, this is a tautology.